Today you want to look at parallel lines. You want to discover something about these two lines that have been drawn here. We have line L1 which passes through point -2, -1 and point 0, 1, and we also have another line that passes through point -1, -1 and 1, 1. So can we get the gradient of these lines? So gradient of line L1 should be change in y, that is y2 minus y1, over change in x, which is x2 minus x1. So we must declare our points. If we say that this is our P1 and that is our P2, then from the point P2 we will get the x2, y2, and from the point P1 we will get x1, y1. So in that case, our y2 is now 1 minus y1, which is -1, over our x2 is 0 minus the x2 here is -2, and therefore that is 2 over 2, and the gradient is 1. Let's get the gradient of the line L2. So gradient of L2 will be change in y, that is y2 minus y1 over x2 minus x1. And we declare our points and say that this is our point P1 and that is our point P2. Therefore from here we get the x2, y2, here is x1, y1. So this is x1, y1, and this is x2, y2. So our y2 here is 1 minus our y1 here, which is -1, over our x2 here is 1 minus -1, and that is 2 over 2, and that is 1. So the gradient of L2 equals gradient of L1. Now if gradient of two lines are the same, then the two lines are said to be parallel. Therefore we can say that line L1 is parallel to line L2. So those lines are parallel. What concept are we getting here? Now in the converse we can say that if two lines are parallel, then they have the same gradient. They have the same gradient. That's what you're saying, that if two lines are parallel, then they have the same gradient. Or if two lines have the same gradient, then those two lines must be parallel. That's what we've got here. The gradient of L1 is 1, gradient of L2 is also 1. Therefore, these two lines must be parallel because their gradients are the same. So we can look at an example on that. If faced with a problem, now a line passes through points 6, 0 and -3, -2, and is parallel to a second line which passes through points 3, 3. Find the equation of the second line. Find the equation of the second line. So we are given the points through which the first line passes through. A line passes through point 6, 0, and negative 3, negative 2. So, very first what you get there is the gradient of the first line. That is line 1. Gradient, we declare this point to be our P1 and this is our P2, from which you get y2, x2, y1, x1. So the gradient will be changed in y, that is y2 minus y1 over x2 minus x1, and therefore the gradient will therefore be negative 2 minus 0 over negative 3 minus 6. And that gradient gives us negative 2 over negative 9, which is 2 over 9. And since we are told that the second line is parallel to the first line, then the gradient of the second line is now 2 over 9. Now taking a general point, x, y, and the given point through which the second line passes through, which is 3, 3. So we can use x, y, and 3, 3 to find the gradient of L2 by saying y minus 3 over x minus 3 is equal to 2 over 9. And you cross multiply, and you have 9y minus 27 should be equal to 2x minus 6. And therefore 9y is equal to 2x plus 21. And this one we can now express in the form of y is equal to mx plus c. It's very important. When you express this in the form of y is equal to mx plus c, we divide both sides by 9 and you get y is equal to 2 over 9x plus 7 over 3. 21 over 9 is 7 over 3. And from here you clearly see that the gradient, because you say that if a line is expressed in the form of y is equal to mx plus c, then m, the coefficient of x, is the gradient. So that is how you go over the issue of parallel lines. Thank you.